Hi everyone, welcome back. I'm covering Appendix F here, time value of money. This used to be an entire chapter in this class, but since they've recently moved this over into an appendix, this is kind of the shortest lecture, but at the same time, in my opinion, the most important. So time value of money is really the basis for finance. It's like your very first class and introduction to finance. So very important concept to grasp, and it's applicable. The reason we introduce it here is because it's applicable to bond pricing, specifically in Chapter 9. So really what we're trying to do here is explain the impact that the time value of money has on certain types of investments. So this is very specific to accounting, but time value of money is a pretty big concept in finance. So what is the time value of money? The concept has to do with the idea that money is going to earn interest over time, right? The word interest is really the cost of using money. So if we need to borrow money or if we lend money, we either pay or earn interest. So again, to a borrower, the interest is a fee or an expense. To a lender, interest is revenue earned. So in life, here's a quick lesson. You want to make sure you become a lender as quickly as possible. You don't want to be a borrower. So let's just look through some kind of examples so it'll make a little bit more sense. We have a few more terminology things. One is present value and future value. So present value and future value. So we can think of present value as time zero, the moment right now at this instant. And future value would be sometime in the future. In this diagram, it's 1 year out. So future value here is the sum of the money that a given current investment will be worth at a specified time in the future. Again, that's going to probably not make a ton of sense to you, so an example is best. So if we were to invest $4,545 today and earn 10% interest, so that's our present value. What would our future value be? Well, it would be $5,000. How does that work? We take our present value, $4,545, grow it by the interest, 10% interest, right? That's the equation here, if you're not sure on the algebra. And that gives us our future value, $5,000. So this is a single sum of money that grows at 10% and it becomes $5,000 at the end of 1 year. So that's an example of calculating the future value. So what do we need in order to calculate the future value of an investment? Well, we need the amount of the initial payment, right? What do we initially pay for the investment, or what money do we initially receive? So, you'll see when we look over how you do this in Excel that you could have initially amount of money that you have to pay for an investment, and then that investment generates some money in the future. We need to know the length of time between the investment and the future receipt or payment. And we have to understand the interest rate. And this is big. If you continue in finance, you will spend a lot of time discussing what is the correct interest rate, and there's many different ways to look at it. Another terminology piece, compound interest. Compound interest is the interest you earn on your principal amount plus the interest you receive on the interest you've already earned. So the interest on previous interest that you earned, that's what makes it compound, right? It compounds on itself. So here is a quick example of how this works. So year zero, our present value is $4,545. We assume here that the interest rate is 10 years, and this is going to grow for 5 years. So how does it grow? The first year, this grows by 10%, so we have an extra $455 of interest that we earn. We have a value of $5,000. Now the second year, not only are we earning interest on that original $4,445, but we're also earning interest on this $455 that gets added to our principal balance. So you see, we earn more interest year 2, and even more interest year 3, and even more interest year 4, and on and on and on and on. And this is the concept of compound interest. So not only are you earning interest on your original amount that you put in, But as that original amount grows because of these interest payments, your interest payments keep going up. So that is the concept of compound interest. Let's look at present value. So the present value is basically the opposite of future value, right? So it's the value on a given date of a future payment that gets discounted to reflect the time value of money. So what does this depend on? We need to know the amount of the payment or receipt in the future, the length of time between the investment and the future receipt, and what the interest rate is. So again, the term that we use here is discounting. Here's the equation. So if we, in this case, we're trying to find the present value, right? What is it? Well, what was the future value? So using our earlier example, 1 year from today, the future value was 5,000, and we divided by 1 plus the interest rate. In this case, it's only one period, so it's just divided by 1.1, and that gives us this 4,545. Just so you know, to be more accurate here, really this should be 1 plus the interest rate to the n. This is the number of periods, okay? For this problem, n equals 1, so that's why they ignored it here. But if this was over 2 periods or 3 periods or 4 periods, then n would obviously be a number up there, and you would have to do the calculation with that exponent. So here we go from future value and present value, and the difference is this interest rate, right? This 10% of earnings. So you can I can give you the future value at 10% over one period and ask you, what is the present value? And you would say the present value is 4,545. Or I might tell you the present value is 4,545, 10% interest rate. What is the future value? You would tell me 5,000, assuming it's just one period. So here are the mathematical equations, okay? This is how you calculate future value. It's just present value times 1 plus the interest rate, as you see, to the n. And present value is just algebraically changing this upper equation around, right? So I'm just flipping future and present value in the equation, and so I get future value divided by 1 plus the interest rate to the n. And again, n is the number of periods like I described in the last slide. So let's do an example here of 2 periods, okay? So the present value that we started off with is 4,132. Let's say it's a 10% growth rate per period, and each period, so this is 10% per year, and we're gonna do it over 2 years. So what happens after 1 year? Well, the 10% on 4,132 is 413. So after 1 year, our balance is 4,545. Then we earn 10% on that whole amount, which is interest of 455, and our balance in 2 years is 5,000. So we could do this exact formula, this exact solution by just plugging it into the formula. So present value is 4,132, okay? Future value is the 5,000. The interest rate is the 10%. And this is 2 periods, right? We had after 1 year, after 2 years. And I can calculate the future value. Here's the future value by taking the present value, 1 plus the interest rate, again, to the number of periods. In this case, it's 2 periods. And the period has to match the interest rate. So this is an annual interest rate. So these are years. If the period was every 6 months, then this might be 1 plus 0.05 to the 4, right? Because we would have 4 in 2 years, we have 4 6-month periods. And every 6 months, we get 5%, right? Because it's 10% divided by 2. So just understand that the period you have up here must match the period that the interest rate is stated in. So here's a graphical depiction of this, right, for 2 years. So times 0, the present value, we have 4,132. 1 year out, we have a value. 2 years out, we have a value. So this would be the future value 2 years out would be 5,000. And this is just the growth here. So you can look at this equation. You can look at it graphically. Take some time with this. This isn't always obvious to people, this topic. So, take it slow, revisit this, work some problems, and hopefully this sinks in. For purposes of what used to happen back in the day, and even of this book, we're going to use something called present value tables. Honestly, this doesn't exist in the real world. I mean, you can Google these, but in the real world, you're going to either use a financial calculator or Excel to do this. And we will learn how to do this in Excel. So the book will walk you through, and we'll walk through in a few slides here how to do it in Excel. But anyway, it used to be that you would just use a present value table. So you could look at the different, either a present value or a future value table. In this case, this is present value of a single dollar. So the way to read this table is look at the number of periods. So in this case, we have, let's say we use that earlier example, the one we started with. We had one period, we had an interest rate of 10%. So the future value times this factor is going to equal the present value. And you can see the future value was 5,000 times the factor that we got here gives us that present value. If you go back a few slides, you'll notice that that's the same number. So that's how you use these tables. If instead this was 2 periods over 10% here, so this is 826, plug this into here, okay? Try that, do 826, and what do you get? You're gonna get what we just did here, 4132. So practice using this table, but again, in real life, you're gonna use Excel or a financial calculator. So far we've talked about single sums of money. I get an amount 5 years from now. I invest a single amount this year. But we may also have things like annuities. And there's 2 types of annuities. In this class, we're only going to cover ordinary annuity. An ordinary annuity is multiple receipts or payments of an equal amount at fixed, in this case, it says year-end intervals. It really doesn't matter. It could be fixed every month, every 6 months, every year, or whatever. The point is you're getting multiple receipts of an equal amount over the investment's duration. An ordinary annuity means it's at the end of the period, okay? This is beyond the scope of this class, but just so you learn some vocabulary, if it's an annuity due, that would mean it comes at the beginning of the period, right? But we're gonna look at ordinary annuities where it comes at the end of the period. So here's an example. So we're in year 0, we're at point 0, right? So at the end of 1 year, so at the end of year 1, we're gonna get $10,000. How much is that worth to us here at point 0? Well, it's worth, assuming the interest rate is 12%, right? It's worth $8,930. It's just, in this case, they picked a factor out of the table. So it's 10,000 times 0.893 equals 8930. Just to reiterate that table, so this is 1 period, 12%, right? And it gives me this factor 893. 1 period, 12%, look at the factor 893. Oh, sorry, let's talk a little bit more about this. So then the next period, you get $10,000. So how much is $10,000 worth today in period 0? Well, this is 2 periods now because we're going from 0 once and then there we get another $10,000, 12%. So this is the factor. So this is how much that $10,000 is worth. Then we get a third $10,000 3 years from now at 12%. It's worth that much. If we add all these pieces up, we get the total present value of this investment as $24,020. Go back to that earlier slide here and find these factors. See, they're right here. And here it is again. So here's another table. In this case, instead of the present value of $1, it's the present value of an ordinary annuity of $1, right? So this makes it easier. All you have to do is look at the number of periods. In this case, we have 3 periods. So we're gonna go here, 3 periods. The interest rate is 12% and it gives you this number. And if you take that number and multiply it times the amount that you're getting each period, you're going to get the present value of this annuity, 24,020. See, came out to the same thing as if we did it in steps. So this is just a shortcut to not have to do it in steps. So Microsoft Excel kind of allow us an unlimited amount of interest rates and periods. So you're going to learn to love Microsoft Excel, and most business people are going to use Excel, not tables. Okay, tables are very much a thing of before computers. So again, if we're going to do the present value of a single payment, then it's the payment that we're getting divided by 1 plus the interest rate divided by n. So in Excel, we can use this to do an exponent. So here's an example of how you're going to find the present value of $500,000 that's going to come 4 years from now at an interest rate of 8%. In Excel, you can just put in the function 500,000 divided by 1.08, so this represents 8%, to the 4th power, right? That's the exponent. So you use this little caret to represent exponent in Excel. Excel also has a function specifically around present values. So to get here, you're just going to open a blank Excel spreadsheet, okay? You can click on a blank cell. Then you'll click up in the menu, you can click the Insert Function button. It looks something like that. Select the financial category here, and then it'll drop down for you a bunch of functions. You'll want to select the function that says present value if you're doing the present value. So select PV from that list, double click on it, and you're going to get this window open up. So here, you're going to put in the interest rate, right? And notice that it also gives you some tips here. So if you're in Excel, you can look at some tips. So this is the interest rate per period. For example, if the periods are quarterly payments and the interest rate is 6% per year, then enter 6% divided by 4, or 1.5%. Also, it tells you any payment you want to enter as a negative number. The way Excel thinks about it is cash going in and cash coming out. So if cash is going out, like you're spending money to invest in something, that means cash is leaving. You want to enter that as a negative. So if they're payments that you are making, that would be a negative. If it's money that you are receiving, that would be a positive. So let's show an example here. So suppose we have an investment that is expected to return $20,000 per year for 20 years with an interest rate of 8%. Okay, so in this case, the period is a year, it's 20 years, so the number of periods is 20. The interest rate each period is 8%, okay? And in this case, they're showing you the payment as a negative because what it'll give you is the present value of this investment is this amount. If you enter this as a positive, then this is going to show a negative. And what Excel is telling you is, in order to buy an investment that earns this percent and gives you these $20,000 payments, this is how much money you have to pay up front, right? So that's the only difference. Try it in Excel. Put this as a positive, and you'll see that this comes out this number, but with a negative. If you enter a negative, then this number becomes a positive, and that's all that there is to it. So what is the point of this again in this book? Well, with this, we don't go that in depth yet into pricing of different securities, but you're going to have to calculate things in business and finance called the fair value of things like available for sale investments. Okay, so at the end of the year, the investor is required to adjust available for sale investments to their fair values using one of 3 different approaches. There's a level 1 approach. This usually goes for investments that have active markets, things like stocks on the New York Stock Exchange or NASDAQ. Those are active markets. You can easily log on and see what their value is. You can do level 2. This is an estimate based on other observable inputs. So like the prices of similar assets. So this thing that you own, this investment that you own, isn't traded on the New York Stock Exchange, so you can't just look up the price, but it's close enough to other things that you can make some pretty good estimates. Then there's level 3. Really, there's no data out there for this specific investment, and you have to use your own estimates and make certain assumptions in order to create a value. And you're going to do a present value of the different cash flows. You're going to assume the interest rate and all these other things to do a level 3 valuation. This right here can be an entire, very well-paid career. You could easily make over $100,000 a year simply doing these level 3 valuations. That is a career, and even a pretty good one. So let's use an example here of how we're going to use this topic in this class, specifically around your investment in bonds. Mostly we use this in chapter 9. So let's go through an example. If we compute the present value of a 9% 5-year bond from Southwest Airlines, okay, so I'm the investor. So the face value of the bond is $100,000. The face interest rate is 9% annually. That means I'm going to earn how much interest every 6 months? Well, it's going to be 100,000 times 9% times 6 over 12, which is going to equal, what, 4,500? So that's how much interest I'm going to get, interest semi-annually. So that's going to be my cash inflow every 6 months. The market interest rate is 10% annually, so it's 5% semi-annually, because again, bonds pay interest semi-annually. So the present value of the bonds is $96,149. How did we get that? Well, let's think about let's break up a bond. So what are we going to do with a bond? Well, we're going to get a single $100,000 at the maturity date of the bond, right? We're going to get our money back. We know we're going to get $100,000 when the bond matures. When does this bond mature? In 5 years. But remember, the periods are semi-annual periods. So 5 years times 2 periods per year, there are 10 periods. I have to do the present value of a bond, I need to use the market interest rate, okay, which is 10% annually or 5% semi-annually. So that's where I get the 5% that I'm going to use to take the present value of a single amount, because I'm going to get this $100,000 just once. If I go back and look at the table of 10 periods, 5%, it should give me this factor. Let's see if that's the case. Let me go and find out if that's the case. 10 periods, 5%. So this is the present value of a single dollar I'm looking. 10 periods, 5%. Gives me 0.614. 0.614. There you go. So if I multiply that times dollar amount, I get the present value of that $100,000 is $61,400. But I'm also going to get an annuity. Every 6 months, I'm going to get $4,500. That's my interest amount. So again, market interest rate of 5%. I'm going to get this for 10 periods. So the present value of an annuity, 7.72. If I look at the table, and I don't know that we have the table here in the slides, but you have it in your book. So if I do that calculation, 4,500 times the present value of an annuity at 5% over 10 periods, the math there is, so that's the present value of those interest payments. When I add this plus this, the present value of the final amount plus the present value of the interest payments, I get the present value of this bond at the market interest rate, right? Again, this is the market interest rate that I have to use to what's it worth is the market interest rate. If I accidentally use the face interest rate, the answer that I'm going to get here is $100,000, because that's how the face rate was created. So how would I do this in Excel? The interest rate for this bond is 5%. This is 10% divided by 2 equals 5% because it's semi-annual. Number of periods, 10. It's a 5-year bond times semi-annual payments. So I get 10 periods. The payment, the interest that's coming in, 4,500, right? How much am I getting at the very end? 100,000. Again, it's showing me in negatives here. If instead I left those alone, then this would become a negative. It's just Excel telling you that this is the money I have to pay today in order to buy this investment that will provide these cash flows for me, right? So just don't get confused with the negatives. But again, the payment amount, 4,500. That's just 100,000 times 9% times 6/12. Why do I use 9% and not 10%? Because the contract on the bond, it's a $100,000 bond, pays 9% interest. The contract doesn't care what the market interest rate is, right? But the value is going to be based on the market interest rate. So you can see Intel in this case has the fair value of its long-term investments and other assets. They have it in a footnote on the financial statement on the 10K, right? And here's the footnote. Marketable equity securities, all of those are just level 1, meaning they're traded on NASDAQ or New York Stock Exchange, very liquid stuff. And they have some other long-term assets, some of which they price at level 2 and level 3 even, right? This is the one, level 3 is the most complex because you have to estimate just about everything. And so that's it. Again, this is a short lecture, but it's a very important one. And a lot of people get stuck on the present value, time value of money concept. Very important that you get comfortable with this. It is the basis for finance. So even if you don't really major in finance, but you go on to take a corporate finance class, this is going to be the basis for that class. So very, very important. See